Okay, so in this example program, we're going to look at using pass by reference and pass by value, and then we're also going to look at how to create a pointer. So here's some functions. We'll take a look at these in just a sec, but let's go down to main. So in main, if you want to declare an integer, it's just the keyword int and then any valid identifier. You could do a is equal to 1, or you could do a open parentheses and put the 1 inside the parentheses. So this will declare just a regular integer, and it'll put 1 in there as the initial value. This will declare just a regular integer b, and it'll put 2 in there as the initial value. Let's say though that we want a variable that's going to point to a memory location. The memory locations, remember, are different sizes depending on what's being stored in the memory. So we need to give it a type. So here's our type. We're going to point to an integer, but we can't just call it a valid identifier, because if we do that, it'll be an integer variable. So we put an asterisk in front of it, and that asterisk in front tells it that it's going to be a pointer to a variable instead of just being a regular int, but the thing that it points to is going to be size int. You could do this with ints, you could do this with floats, doubles, even things like strings. So if we want to set the pointer to now point at A, we can use this reference operator. So this is a single ampersand in front of the name of the variable A, and that'll move the pointer so that now the pointer is pointing at the memory location that A sits in. So let's print out a few things. So let me run the program so we've got the output, and then let's talk through the output. So it's printing out here A is equal to, and then it prints out A just the standard way. So we put a 1 in A so the 1 prints out. We can also use this reference operator though to print out the address of A. So here where it says address of A equals, you can see there's this hex memory location. This is just a memory location inside your computer, so if you run it on a different IDE, or if you run it on a different computer, or sometimes even if you just run it at different times of day, you'll get a different memory location allocated for that variable. So this is just where it sits inside the computer memory. So here's our value of pointer. So pointer now contains that memory location where A is located. So it contains, basically, we'd call it the address of A. But the information where it's stored is actually stored at a different location. So we can also look at the address of the pointer, which typically we never care about. It's just stored in memory somewhere. But you can see that it's in a different memory location than A is stored in. And then if you want to use the pointer to get the value stored in that memory location, which was the 1, then you just use the asterisk, or also called the dereference operator, in front of the variable name PDR for a pointer that we defined up here, and then that'll give you what sits in that memory location. So let's do a little work with our pointer. Let's make our pointer point to something else. So we can make our pointer point at B. Just do pointer equals, use that ampersand again in front of B. So now it's going to point at the address of B. And if we print everything out, it's going to be B stuff now that prints out, because that's where the pointer is pointing. Notice though that the memory location where the pointer is stored stays the same. We're just changing what's in the memory location. We're not changing the memory location of the pointer. Now we can also use the pointer and change what's stored in that location. So we could do the asterisk, so the dereference operator, and then the name pointer, and then do equals 999. So this is going to take the 999 and it's going to store it in the location that the pointer is pointing to, which is the location of B. Now if we print this out, we can see that B is now 999, and the pointer is pointing to B, which is 999. So let's look at also passing a pointer to a function. So here's example function, and to send a pointer, you just do example function, open close parentheses with the name of the pointer inside. Notice that you don't include the ampersand or the asterisk, so no reference or dereference operators. Let's look up and see on the receiving side of this function. So this is this example function. So here on the receiving side is example function, and we do have to do something on this side. So the pointer's pointing at an int, so we need to have int in the argument list, and then we have to say that it's going to be a pointer that we're receiving. So we'll do the asterisk in front of it, and then the name that we're going to call it inside the function. Looking at it inside the function, you can see we've created a new local pointer, so it's stored in a different memory address than our pointer that was in main. But since we passed what was inside that memory address, now that new pointer is pointing at B, and so we can get the value of B from here. And then if we do the asterisk again and then do new underscore pointer equals 1, 2, 3, 4, it's not going to change pointer, which is in main, but it'll change the thing that pointer's pointing to, which is B, and change B to 1, 2, 3, 4. So now let's look back in main, and then after we come back from that function, we're going to print out pointer. You can see the pointer is still pointing at B. The pointer still has its same original memory location because it's the same pointer that's in main. It's different than the one that's in the function, which has a different memory location. But you can see that B was changed. Therefore, when we use the pointer to get back what was in B, it gives us the 1, 2, 3, 4 that was set in the function. So you might say, why would I ever want to use pointers? Pointers wind up being a really powerful way to pass things in C++. And so we'll continue to talk about pointers as we go. But there's not a lot of applications for pointers in the program that you're working on right this second. So I'm just trying to introduce the concept now, and then we'll talk about it more as we go. It's kind of a complicated concept. So I wanted to spread it between a couple of lessons. What is really important though now as we talk about passing things to functions is this concept of pass by reference or pass by value. So let's do two functions. One is a pass by reference, one is a pass by value, and see what it does. So we're going to set up a string, and we're going to put hello world in the string, and then we're going to do this function do nothing. So when we look up here on the receiving end of do nothing, it's receiving the string, standard string, and this is what's called a pass by value. It's receiving not the whole string, it's just receiving a copy of the contents of the string. So in this function in here, we're going to look at each element of the string, and we'll continue talking about how to look at each element as we continue to talk about strings and vectors. But we're going to take each element of the string, we're going to use this function toUpper, and so we're going to convert it to uppercase. But then when we return, all we did was we changed a copy. So then when we go back to main and we try to print it out, it prints out with the same capitalization that we defined it with. It didn't do nothing, didn't change anything in here. But we can do a different function that will actually change it. So we call it the same way. So it's change case in this case, and then open close parentheses and just the S to pass the string to it. But on the receiving end, it's going to look different. On the receiving end, compare these two together. We've got standard string, but then we have that ampersand location. And so the ampersand operator is saying, pass me the location of string. So when we pass the location of string, then we get the whole thing. and whatever we change up here in the function also changes what's back there in main. So we're going to run the same to upper, and then we're going to return and then print it out. And when we print it out, you can see the whole thing's converted to uppercase. So a couple things to watch out for with these. When you've got the asterisk in here, the asterisk is this dereference operator, and that's indicating that you're using a pointer. When you've got the ampersand is indicating that you're referencing the location that something's stored in. So that could be to move a pointer to make it point at something new, or it could be on the receiving end of a function. So this would be the receiving end. This function's receiving this value in, and then it's a pass by reference. Whatever you change in the function changes it everywhere. Without the ampersand, though, it's a pass by value. So the function only gets a copy. The function can change the copy, but the copy doesn't change the original. So the pass by value, you're only changing a copy. Pass by reference, you're receiving the original and you're changing the original because you're basically passing a pointer to that memory location. So it's a lot of kind of difficult concepts in this, but these are really important in C++. One thing to be careful about is when you're using pass by reference, for right now when we're doing mostly engineering calculations and things like that, you probably want to mostly use pass by value so that your function doesn't accidentally change something and you don't realize it. But pass by reference can be very important when you're passing really large objects, and it's going to give you a lot of flexibility if you continue programming in C++. It's a little bit out of the scope of this course, but using pointers and being able to pass through pointers and pass by reference really gives you a lot of flexibility and opens up a lot of really powerful programming concepts. Thanks for watching.